I'm going to present on a small grab bag of topics, but I promise to you that they are related. So we're going to spend a little bit of time looking at the micro details of access control policies, and then try to describe where that fits into a broader space of user experience. So there's a lot of things that we can say over the wire and write down in FHIR expressions, but what does this mean for real human beings who want to make sharing decisions and maybe share some of their own data for specific purposes? And then zoom out a little bit more and talk about some of the cross-organizational policies. And in particular, I'll use TEFCA as a small case study for cross-organizational exchange. So you've got the links to all this if you want to follow along on your own. But I'm going to start off with some of the capabilities in the Smart App Launch specification. And it's worth saying this is sort of technology that is very broadly deployed today. So in the US, this is part of our certified EHR testing program. So anybody with a certified EHR will be able to do these first things that I'm talking about here when it comes to granular scopes, at least at the resource level. And then we can get down into things like categories. So the Smart Implementation Guide describes scope language that allows you to approve an app to access certain subsets of data. And the language basically consists of what we call kind of a level. And we'll talk about examples here. A FHIR resource, so what types of resources are we talking about sharing and read them? Or are you allowing a client to create them and update them and delete them? And then if talking about just one resource category alone is not enough, we also allow these to be narrowed down using FHIR search parameters. So for example, using this scope language, you might say something like patient/observation, this should say R or RS. I'll fix that in the slide, and category equals vital signs. And what that means is that you're going to allow a client application to read and search for FHIR observations if those observations have the vital signs category attached to them, and only for the specific patient that is in context in your authorization. So we call this a patient level authorization. And it covers a really common case where an app has been launched in the context of a single patient record. So this could happen when a doctor is opening one patient chart in the EHR, or it could happen when a patient is sharing their own data with an app of their choice. So that's the basic that we have. And the example I showed you so far was patient level. Let's talk about user level for a second. So here we don't assume that there's just one patient that the app will be able to access. Instead, we look at this as a delegated scenario. So the end user, the person at the keyboard, or if I am a parent and I have access to 2 children's records, well, I want to be able to share those 2 children's records with the app. So we call those user level scopes. And they really highlight the idea that smart scopes are grafted onto some existing access control system. So like there's an EHR or a patient portal that already knows who the users are and generally knows what kinds of data those users are allowed to see. And so Smart provides a delegation mechanism so users can share the access they already have with these apps of their choice. And then finally, we have a system level. And this accounts for a scenario where there might not be an end user in the loop, but we just have some kind of a backend service running on a machine somewhere that's able to issue queries directly to another machine somewhere. So maybe you've got a lab interface engine that's receiving results from an outside lab system and posting them into the EHR. And there's no human sitting at the keyboard approving that access as it flows. So that might be a system level scope. And with this language, you can say reasonably flexible things. So you can say things like, I want to provide read and search access to all vital signs about the patient in context. Or maybe you've got a family member who's managing immunization appointments for all of their children. So that app might be able to access immunizations with user level scopes. So that might pull together the immunization schedules for your 2 kids and allow you to see those on the same page. So you can consolidate the appointments that you're trying to book. Or in the case of the lab interface engine, you might say, I'm allowed to create new observations with the system level scopes. So one system connecting directly to another in order to be able to post data in. And that's very common for kind of business-to-business integration scenarios. So those kinds of scopes are part of the current certification system in the US, and EHRs need to provide access at the resource level, and then also for a few resources like observations and conditions, the requirements are coming in at the category level. So it's fairly coarse-grained. I can't say things like, I don't want to share observations from the year 2020 if they had to do with a certain diagnosis. You might be able to write that down with a smart scope, but we don't expect that real EHRs are going to be able to support those kinds of dynamically constructed scopes. Instead, we have a finite list of them that are just resource types and categories that are published as part of FHIR US Core Implementation Guide. And that serves as the basis for consistency in these real-world systems. So I want to call out one challenge with this scope language, which we've heard from a number of implementers who are maybe building their own FHIR servers or using native FHIR servers to do more than just providing access to something like US Core FHIR data. And this challenge has to do with what FHIR calls custom operations. So FHIR has essentially its own RPC framework called operation definitions, where a server can advertise that it supports certain operations, and the operations have a name and some inputs, and they can produce some outputs. So in Smart, we don't have a standard way to express permission to execute a certain operation using a scope. So you might want to call the bulk data export operation on a group of patients, or in order to get an exported data set about all of them. Or maybe you want to call the purge operation on a specific patient to say, I want to make it look as though this patient was never in the EHR, erase all traces of that patient's history. Or an example that somebody shared recently on Zulip, maybe you want to give a back office staff member very specific permissions, like maybe you've got an update name operation, and you want to say that this staff member can, just have access to that one operation to make targeted changes to a patient record. It's very difficult to account for all of the variability in what you can do with FHIR operations in a standardized kind of scope language. So one thing that's important to understand is that these FHIR operations can attach at different paths in the server. So you can have some operations that you call on the server root, or some that you call at the resource type level, like group/export. It's not associated with any particular group in this example. It could be, that would be the type instance level. So if I want to export all the data on group number 17, that would be attaching at the instance level. So there's one point of variability. Another one has to do with the input parameters. So maybe you want to say that a particular user has access to call this operation, but only with certain kinds of inputs, restricted in a certain way. So your scope language would need to be able to say something like those restrictions on the inputs. And so for all of these reasons, we have not yet tried to standardize a scope language for custom operations. Our kind of simple advice right now is if you've defined a custom operation and you want to use it in OAuth scope name. So, right now our advice is just use your operation definition as a scope name. If you need to attach more restrictions, you can come up with a syntax to do it that makes sense in your use case. When we look ahead, when I think about how we can make progress on this over time, one area where I think we could make some meaningful progress is to focus on the data access rather than the specific operations that you're allowed to call. So it'll take the bulk export operation as an example. You can actually describe who's allowed to call these operations pretty well just by describing the data access patterns. So if you want to export data on a group, you'd better have access to the group and the patients in it. And so you could actually attach your permissions to the underlying read access to those groups and patients. Rather than having special permissions for export, you just say export is an operation you can do when you're allowed to read the data. And you could do something similar with patient update name. Rather than saying we've got this special operation and I'm going to give you permission to call it, we could say, well, this operation is always governed by who has update access to the patient address element. And that gives us a target for authorization policies that is a lot more consistent. The surface area is narrower. I don't know exactly what the syntax would look like for that, but it could be something like the example here where you say, I'm going to give you access to update patients, but only at these specific paths within the patient resource. So if there's interest, that's a concept that we might try to take forward with a future publication of smart scopes. So that's the sort of narrow, nitty-gritty scope language part of the presentation. Now I want to zoom out and say that from a user experience perspective, it can be really complicated to manage these kinds of scopes and approvals. And if you're a patient accessing your own records from an app, you can come up to a scenario where you are trying to provision access to a health system. And I'm going to see if I can do a quick demo here of just sort of sharing my own health records from my own healthcare provider organization. This is one where the app requests access to basically all the scopes it's allowed to under FHIR US Core, which is a whole bunch of categories. And the Epic MyChart interface displays a couple of screens. One that tells me as the user a little bit about the app. This is self-reported data from the app developer. And then there's this checkbox page, which shows me all the categories of data that are being requested and allows me to sort of check and uncheck them one by one. And if you drill in, these sort of correspond to the categories of data that are made available in FHIR US Core. So immunizations is at the category of a whole resource type in FHIR. But when it comes to observations, you can see these are being grouped together. Lab results, smoking status, vitals, these are 3 different categories. But over time, as this system is updated to support granular scopes, there will be probably 3 different checkboxes here, one for each of those subcategories. And you can see from a patient perspective, this is on the one hand, empowering. I've got so much choice. I can really tailor my access policy in a way that makes sense to me. But on the other hand, it can be overwhelming. I've suddenly got 40 checkboxes to deal with. And if these defaulted to unchecked, instead of defaulting to checked, you might imagine that most apps never got or would never get most of the data they needed because patients wouldn't realize that they had to individually check all these, or they might not know exactly which ones were important. So this user experience really dictates a lot. And then at the end of the day, even if we have fairly granular scopes, there might be some things that are really hard for me to say as a patient. Like maybe I want to take away data about pregnancy or smoking status or drug use. If we don't have predefined scopes for those things, there might not be a consistent way to say it in different health systems. So I do just want to say that all of this user experience around sharing access to data where it sits has these kinds of limitations. There are other user experiences that you can build around health data sharing, and they have their places and purposes. So one example is a project called Smart Health Links. This grew out of work that we did as part of the pandemic response to help individuals share their COVID vaccine histories and COVID lab results. And in that context, we wanted to give consumers the ability to save a copy of their data and share that specific data set when they chose. And we had a system of doing that with QR codes that was called Smart Health Cards. And this new work with Smart Health Links builds on that, but it allows the consumer to put together a data set that they want to share. They decide what's in the data set. They might use their own apps and tools to put together a bundle of data that makes sense for a particular purpose. And then once you define that bundle of data, you can share it in a standardized way. So this Smart Health Link example here points to an encrypted file with my FHIR observations. In this case, it's going to be showing my own blood glucose measurements over the course of the last couple of months. So anyone with this link can automatically download a FHIR bundle. You can write like a 10-line JavaScript program to turn this link into a FHIR bundle with, in this case, about 6,000 granular FHIR observations representing specific glucoses at points in time, as well as high-level summary observations with these kinds of statistics, and also a PDF of everything you see on the screen here. So anybody with this link can automatically turn the link into that structured data payload. Or if you don't have software that knows how to process Smart Health Links, you can just open the link in the browser and see something like what you've got on the screen here. And if you want to see what the data actually look like, you can click this download button and you'll get that whole bundle with 6,000 resources in it. So I call this out as a different sharing mode. It's not suitable in all of the same scenarios that you might use something like Smart on FHIR for or something like TEFCA for, but it's very powerful for the places that it works. And it kind of flips the sharing paradigm on its head by allowing consumers to be in charge of what goes into the data set rather than trying to filter things at the time that a query comes through. You don't need a very expressive formal language. You can just make decisions, and then those decisions result in a data artifact. So that's Smart Health Links. And I should say this is a specification that was community developed, and it's currently going through an HL7 standardization process. So the goal is to bring this into the HL7 ballot for the September cycle. So if this is interesting to you, that's a place where you might want to follow up. And then the last quick topic that I have here has to do with network-based exchange. And here the policies are really interesting because the way it works in the US today is that organizations kind of sign on to these networks by forming agreements with each other. And there's a common agreement, that's the CA of TEFCA, that tries to provide some consistency in the way that these work. But essentially the agreements put in place certain policies about who's allowed to query for what and under what circumstances, and who's required to respond to these queries. And basically the way these networks work is that once organizations sign into a network like TEFCA, they become a participant or a sub-participant in the network. And then you, let's say as a healthcare provider organization, can send every other healthcare provider in the country. And you could say in your query something like, I'm seeing a patient called Josh Mandel. He was born on this date. He lives at this address. Do you have any information about Josh? And the idea is that, thousands or tens of thousands of organizations would see your query and decide if they had information that matched the patient you were asking for, and respond with a set of details like patient IDs that would allow you to then follow up and request documents about that patient. And if you think about the permission model here, it puts a lot of trust in these network participants, expecting them to do the right thing and follow the rules. And that is really nice in situations where it works, but it quickly gives rise to these kinds of gray areas where you might see somebody sending a request. The network participants don't necessarily get a chance to review it and think about it and apply a sanity check. They're supposed to just respond because the query is coming from a network participant, and network participants have agreed to only act in good faith. So you could see where this might break down. And there's a recent case that I won't go into the details of, but where one participant in the network was sending out queries that other participants decided might not really be related to patient treatment, even though the queries purported to be about patient treatment. And this points to this kind of trust decision. And right now, the way these trust decisions get adjudicated is that the TEFCA coordinating entity can sort of look at the facts and try to make a judgment call. And as soon, if they can't agree, then ONC can get pulled in and asked to adjudicate any differences of opinion. But from my perspective, one thing that's really missing here is a role for the end consumers, the data subjects, the individuals whose data are being queried and shared every day. And I'll say just really briefly, for me, there's three principles that it would be very good to build into TEFCA with respect to individuals. And I think this kind of transparency could lend to much better trust in the network and better functionality overall. So one is that individuals should be able to see their own data. And in theory, this has been part of TEFCA since the beginning, but in practice, you still can't do it. So it's a good principle. I think everybody pretty much agrees with this one, and it's even part of the rules, but still not really working today. The next one is that patients should be able to tell when their data are being queried. So like as a patient, I think I have a right to know, did somebody just broadcast a query to 10,000 clinics asking about my data? If 10,000 clinics were able to receive that request, I should be able to see it too and know when that is happening and who's responding to it. And this principle is not really one that people seem to agree with very broadly today. This is not baked in the rules of operation or the expected TEFCA functionality. And I think it should be. I think that's an area that we could really dig in. And the third is, I think that to be accountable to patients, we also need to give them some controls over what data gets shared. And in my ideal world, that would look a lot like what John showed in the last segment. You would let patients describe what's not supposed to be shared and with whom. I think we should try to get there. But in the absence of that kind of rich functionality, I think we should at least give individuals the ability to opt out and say, you know what, I don't want my data being shared automatically without me. I'll take the responsibility of moving it around myself if I think that's important. And I don't know personally whether I would take that option, but I think offering that option is just part of what it means to build a system that is accountable and transparent. So out of these three principles, this first one is the only one that TEFCA is at least trying to meet today. The other two really haven't been agreed on by the community as something that's important to build. So those are three topics. I hope it gives you something to think about, and happy to follow up in the discussion afterwards.
Thank you. At least the last is a huge topic to discuss, so we can spend hours and hours. So maybe let's answer one question from Mark. Can you formulate it?
You may have touched on it, Josh. I was looking in, as I'm writing the specs for payer data exchange, we're dealing with potentially system-to-system exchanges that may want to be scoped. So I was trying to come up with a smart compliance scope for effectively maybe querying. You could be querying a group resource, but you maybe not be at the ID level. And you, for example, we've got a member match operation that you want to be pretty open, supply a bunch of data. Do you match any of these members that I've sent you? The data export operation that should be restricted to the IDs that you have got permission to use. So basically at the group/ID level. And, I was just trying to come up with a terminology based upon what the great stuff that you've done. So definitely would take any insight. I think it is something that is needed to be able to consistently define the access to operations and scoping that, particularly for system to system, that it shouldn't be just open access.
Yeah, so thank you for raising this. And I totally agree. It shouldn't be just open access.
Yeah.
So it's important to be able to express these permissions. And the way that we generally break this down in SMART is we say there's capabilities in the underlying system, and those we don't try to model in a standard way. We just say the underlying system is responsible for supporting, for example, the idea that Mark as a user has access to these 3 patients because they are his children, or he's a designated representative for them. That's an example of something that can live in the underlying authorization system. Another example here would be the fact that this particular OAuth client is associated with a certain group. That's a policy that could live in the underlying system. And if you manage to factor it this way, then your scope could just say, when I get this particular access token that I'm going to request right now, this access token will have, the read scope on all kinds of patient resources. And what that means is all the patient resources I'm allowed to access. And which ones is that, which specific patients is that? That becomes an underlying system capability tied to a group. And I think that reflects a pretty common practice that we're seeing from the certified EHRs that are meeting the ONC rules, because what they're required to support is client registration and then the export of data within a group. And so the typical flow here is that at registration time or just after registration time, your client becomes associated with one or more groups. And then you can call export on those groups. And if you try to call export on a different group, even though you won't have the ability to call export on a group that you're not associated with.
Right. Yeah. Cool. Thanks.
Josh, what do you think about kind of other kind of more complex operations? Because group export, $, everything is more or less kind of like a query into to a certain extent. You're just asking for a data. But there are much more complex scenarios. For example, if I define $ prior authorization submit, I don't know exactly what implementation might be behind the scenes, because someone might use temporary resources like task resource, for instance, to store some status of how it goes. Someone might not. Someone might store claim resources in the FHIR repository eventually just to reflect them. Someone might not. So there are too many nuances on the implementation, and basically from Smart on FHIR scopes level, it's really hard to say which scopes you need, because I would just say, I mean, and the use case is quite straightforward. For certain, kind of providers, I may just say, I'm not giving you any access to my resources in my FHIR repository. I don't want you to come and do any queries, but I'm giving you just this prior authorization endpoint. This is all what you have. Submit data, and I even don't want to tell you what I do behind the scenes, which resources I do write, read, and stuff like that. I might not even have like real FHIR server behind the scenes. You see, it might be like just like, endpoint doing some magic. So with that, just my opinion, we need somehow to say these endpoints are open for you, these are not. And even in Mark's example with kind of, we have member match operation in the scope of pair to pair. But what I would do, I would say, yes, endpoint is sort of open, because before you do any data extract, you need to find these members. But I would say I have these 10 client IDs that I've assigned for pairs, and I want only pairs to call this member match operation as many times as they want. But if it's some third party, iPhone app, I don't want it even to try it. It just doesn't make sense, because even the data is safe enough, it will be just, useless connectivity and stuff like that. So I would say I want to say for certain clients which operations are accessible in general. It's really convenient to get this level of abstraction. I mean, I'm just sharing some, experience from P2P and from...
Yeah, no, I totally agree. I think the challenge is figuring out how to standardize these. So, my only insight here would be to say there are some kinds of operations that boil down to simple data reads and writes. And for those, we should try to model them with simple scopes that talk about the data reads and writes, instead of going up to this level of an opaque operation ID. But as you point out, there are other operations that can't be modeled well that way. And for those, I think just treating the operation definition itself as an opaque label and saying, great, you've got access to this thing. The server can easily manage that by tracking the operation definitions it supports, and just use the operation URL as a scope. That gets you reasonably far in terms of what I think is kind of the efficient subset of this that we can standardize. If you come back and say, well, yes, but we want to provide access to the prior authorization scope, but we also want to say in a standardized way, in band, that it can only be called with input X in the first position and inputs that match regex Y in the second position, there I look at this and say, okay, I think we won't be able to standardize at that level. So there's some sweet spot beyond which it becomes really difficult to get consistency. But I think for the examples that you just described, Artem, that is something we should be able to model pretty effectively with just opaque operation definitions as scopes.
Yeah. I think it will basically cover the most of use cases that they have, because you see kind of basically, I would say from pairs perspective, there are 3 types of actors that can connect. It's another pair. I define this client ID is for this pair A, and this pair can do member match export on groups, because I don't want even maybe to query my data. I expose group export, and this is enough. And I say, this is prior auth for you, maybe something else. I don't remember what's applicable. Next, I say this client is for provider. So you can do provider access API. Maybe you can do something with CDEX or something else. And like custom applications, like mobile phone applications, they do $ everything and standard queries. And in order to reconfigure them, I just need to define operation. They can come to my server, and that's it. So it's quite straightforward for me.
Yeah, I think that makes sense. And the other possibility that this raises is, in addition to providing scopes that pertain to one operation definition, you could also think about modeling those client abilities with a capability statement. These are the operations you're allowed to call, bake all of that into a capability statement, which has a canonical URL, and then use that canonical URL to sort of encapsulate the whole set. So if you find yourself having to come up with long lists of scopes every time, maybe you just want to summarize it and just say, this client is allowed to do the things represented by this capability statement.
Yeah, by the way, this is a really good idea, because so far I've been thinking about it from the perspective of like having one capability statement in terms of what the server generally,
yes,
like a max possible variance can do. But this is actually wrong, because any pair connects to another pair. They don't even need to know what it's capable of doing. You just need to understand if I can do pair-to-pair and prior auth, for instance. It's supported. Okay, I do this operations. I don't need anything else. Yeah, this is a good idea, actually.
Okay, guys, sorry for interruption. At least we have one good discussion. So let's think it was the first part of roundtable.
Thanks, Josh.
A very interesting topic. So thank you, Josh. Thank you, guys, and let's move forward.